Hi guys, here's your video for working with Exponents 2, and we'll talk a little bit about solving exponent problems by sort of transforming them into having the same base. So here you have sort of some notes that you can take a peek at here. So if the base numbers are the same, that means that their exponents have to be the same. So if a of x is equal to a of k, then a must be equal to k. So to solve for x here, what I want to do in this first problem right here, this is the same thing as 2 to the x power is equal to, and I want to think about 2 to the what power is going to give me 16. I know that 2 to the 4th power is equal to 16. So here I have two things that have the same base. So now I know that here x is equal to 4. So coming over to this problem over here, 3 to the x plus 2 is equal to 27. I know that 3 to the x plus 2 is equal to, and I know that I can write 27 as 3 to the 3rd power. And then I can keep going with that and write 3 to the x plus 2 is equal to 3 to the negative 3rd power by using my properties of negative exponents. So now, now I know that x plus 2 is equal to negative 3. So I can subtract 2 from both sides, and here x is equal to negative 5. So you can go ahead and you can go through and do some of these problems. Looking at something like this problem right here, the first thing that I would do is change this to 2 to the 3rd power to the x. So notice how I just replaced 8 with 2 to the 3rd is equal to 2 to the 5th power. So this becomes 2 to the 3x is equal to 2 to the 5th. So 3x must be equal to 5. Divide both sides by 3. And here I get that x is equal to 5/3. So again, you can just go ahead and go through and solve some of these problems. They do get a little trickier down here, so I'll just go ahead and explain this problem here. So 4 to the x plus 2 to the x minus 20 is equal to 0. So what they really want you to do here is compare this to a quadratic function and for us to sort of factor out a quadratic function. So what they did was in this example, and I say they as in the people who wrote out these notes, 2 to the x, they're sort of treating like m. So at this step right here, I could call this m squared plus m minus 20 is equal to 0. And you can see that they went ahead and factored here. So they really factored as m minus 4 and m plus 5 is equal to 0. And then they went back in and they plugged in 2 to the x for m. And here they were able to solve. So I know that this can't be negative, so this one will not produce any real values. So then that's how we ended up with x is equal to 2. So try to see if you can make these problems down here have the same base. And if you need to, sort of pick a variable to substitute. So for example, this could be 2 to the x squared minus 6 times 2 to the x plus 8 is equal to 0. And as we're factoring, to make this look a little easier, we could call this m squared minus 6m plus 8 is equal to 0. And we could go ahead and do our factoring with m in case this is looking a little bit confusing. So good luck with some of these problems. I'll post an answer key for you to check your answer with, but I really would like you to show your work and give these problems a shot. Good luck, guys.